Welcome to the project, everyone. Today we have yet another fun one, another tool to work on. So if you've watched the scroll saw video, then you know that I mentioned I bought two tools in one day and they both had issues. Well, this is the other one to that fun day. So as you can see, it's a Husky Air Compressor, and this is going to be a huge upgrade to the shop if we can get it working. Because let me show you what I currently have and is a big pain, and then you'll see why this is going to be a little bit better. Not the best, but you know, it'll get us by. So let's go look at it. So let me preface all of this that my current air system is not ideal. Like, I don't have water filtration or anything like that, but I'm also not ever really using any tools that I care to use for a long period. So this whole air system I'm just kind of considering as like throwaway. So try not to get too mad at me for like how unideal it is. But we come under here, so at least it'll help block the noise a little bit. We have another Husky Air Compressor. This one is just a little 8-gallon. It says 4 CFM on it. Like, it's a tiny, tiny air compressor, and as you can tell, I have the cover off from there because I've had to fix it up a few times. And this one, like, it's okay. It's gotten us by. But, like, this regulator right here, like, flips. If it can do, like, one charge cycle, and then this will flip off. So I can, like, fill up a couple tires, and then once it kicks on, I gotta let it rest. I gotta let it cool down before I can use it again. And some of that might be because of taking that off. But anyways, this has not been ideal. And I'm hoping that this new air compressor can really bring up our quality in the shop here just a little bit. So this new compressor is a ton more storage. So we got 26 gallons rather than 8 gallons. It goes to 150 and it does 5 CFM at 40 or 4 CFM at 90. The other, so like a little bit higher CFM, a lot more storage. Should be a lot better. Oh yeah, and listen to this sound. You ready? Yeah, that sounds fun. So, yeah, it's not really much higher CFM, which means, like, we can't necessarily continuously run a bunch more stuff. But with it being 26 gallons, and if we can fix these issues, because, again, that one has some of the same issues. If we can fix the issues, then this should at least make it so whatever we want to do, we can do just fine. If I want to use air to blow all the debris off the benches for, you know, 10 minutes, then this should be able to help with that, or do something else. Man, that was very descriptive. But there are some issues. So there's two main issues. One of them I knew about, and the other one I found out when I got there. Let's show you the first one. And I would show you some of the placards, but there's honestly not a lot of fun ones on this one. You guys didn't know, almost all air compressors have a valve on the bottom, so that way when moisture rests on the bottom, you can just like let out some of the moisture, but this is really hard to turn. I would love to eventually put in like a little electronic valve that just for like once a day or something to drain water. See, look. Tilt tank to drain. Drain tank daily or after each use. Tilt tank to drain. So they want you to tilt it like this? How are you supposed to get the moisture out? Anyways, that's in. Now we can start pumping it up. Oh, that's closed. Alright, plugging in. Okay, so here's the first issue. This is the intake. I don't know if you can hear that. Do you guys hear that? You guys hear that? This is the intake. You should not be having air come out the intake. So, there's one issue, and then we'll show you the second issue. Alright, so as you can see, here's the second issue. This circuit breaker right here, which I think is overheating of the motor, kicks off. And look, we're like halfway up. We're like, what, 60, 70 psi, 60 psi. So there's the second issue. Okay, so here is my thought process. Well, first let me maybe explain how this all works. If you don't know how air compressors typically work, this is like a piston style air compressor. So we have a motor here, we have a piston here, and some valves in the top. So the piston basically just pushes air in, sucks air in from outside. So it just pushes all the air towards the tank. This specific one, we have air into the tank, air coming into this regulator. So this is what's going to turn off the motor when it gets to the pressure it needs to, and kick it back on when it gets too low. So this is going out, and this is where we connect in, and this is a regulator. So if we want to run like a lower pressure, then we can have a higher pressure in the tank. We got a little bleed off valve right here, which might be for draining the whole tank, but I don't know exactly why they have these here. But so here's my thought process with these two issues. This circuit breaker, I think, is built into the motor, but we'll figure that out when we dig into it. And the air coming out is saying that like the piston is bad, or the valves are bad up in here. My thought process is maybe this isn't an issue. Maybe it's just this issue. So like right now, it's not leaking air because it's all hot. It's really hot and everything's tightened up. But if the valves are bad and letting air back out once it's cool, then that probably means that this thing runs really inefficiently right now, which means this is going to overheat. So if we can fix the valves and make it compress air more effectively, then this is never going to overheat and kick off. Let's start tearing into it. We got to drain the tank so that way we don't have compressed air while we're trying to work on stuff, and then we can start taking off these covers. So let's get to it. So here's a better shot of how this all works. So we have our piston rod right here. This is like our crank, and it's kind of counterbalanced, as you can see. And so as this goes around, it pushes the piston up and down. And then the piston up here, it's just going to be some simple valves to suck in this way, push out that way. So right here, this is where our issue is going to be. Might try to dust this off a little bit and then get into up here. I just love having clean equipment. It's hard not to enjoy clean equipment and then want to clean everything. Plus this, you know, I don't want to get dust into everything when I take this apart. I know it's not a motor, but like an internal combustion motor, but still. Maybe we'll blow that off really quick with our slightly working air compressor. Well, I was just going to take this off, but we should probably pull off these lines first. Wait, I want to go this direction, I think. Yep. All right. Time to see what this looks like. So it looks like there's just a simple valve plate. Here's all the valves. So what happens is pulls air in through these. And this is a lot like the generator with the fuel pump. So these valves will let air, they'll fall down and let air down into the piston, but then when it pushes back up, it'll close them off. But then there's valves on this side that close it off. So to get a leak all the way through, both of these valves have to kind of not be working. So these don't necessarily need to work insanely well. It's these valves that hold back the pressure from the tank that need to work really well. And as you can see, most of them, so these valves, you can see they're kind of sitting up a little bit, and I don't think they're supposed to be like that. Down in there, I don't know if you'll be able to see that, but down in there, they're also lifted up a little bit. All in all, this is really dirty. So this might work just from cleaning this all up. There are some scratches here at the top, which I find very interesting. Yeah, so right here, there's like little impact marks. So it might be that this piston right here is also getting a little shot. You can see it just all pops out as like one little piston set. But yeah, so let's clean this all up and see if we can adjust something. The top is literally just holes to each side. Before I clean this up, I just want to say, like, hopefully you can see the, like, all the crud built up around these rings. And again, these are the sealing surfaces. So if there's crud in there, then there's going to be gaps in other places. So maybe that's our whole point, like, or that's our whole issue. Yes, on these reed valves, I want to make sure that they're like making decent contact. They want to sit just barely touching it, so that way it'll be easy to open it up and let it through, and easy to close it down and keep it pressurized in. But this definitely, like that crud right there, yeah, that's no good. Let's clean it up. See, like I cleaned up the crud around that ring, but that ring has still a bunch of crud in there. Hopefully that'll help this all out. I will say there might be a little bit of pitting in there, but we should be good. Well, we got those cleaned up pretty well. So you guys see how these are like rounded to like let the air flow cleanly through there, but there's a bunch of burrs inside there. So what I'm going to do is take my microfile set and try to clean up any burrs or any disturbance to the air, because I want them to like flow as efficiently as possible. So we're just going to clean up all of these holes, but again, without trying to touch the sealing surface on this side and on that side. So okay, so we got those holes cleaned up. We're just trying to remove any machining defects, because again, this is just mass produced, so they just injected it in. I think these are the pins that they like push it out with, and they maybe injected in all the aluminum from over here. So we just want to clean up any machining marks, because the parting line of this machine, so they like have two molds and they come together right in the middle. They fill it up, let it cool, pop it out, and push it out. So there's a parting line in all of these holes, and so we just cleaned them all up, rounded out the the chamfer coming into there, and I think we did a pretty good job. So next step, let's clean up these valves carefully, get all the junk off of them, and on to the next part. Alright, well, I've cleaned everything up. I mean, even this is a bit quieter. Maybe there's some junk in here that we kind of cleaned up. So one thing I noticed about this is there is no bearing between the piston rod and the piston. Like, right there, you see that rocking? It's because it's literally just connected to the piston rod. And it looks like there might have been some contact. I don't know if this is hitting the cylinder head. This air compressor has definitely eaten a bit of dust and other debris because it's been a little interesting. Yeah, just there were some dimples here as if it sucked in some debris, and yeah, and I just want to flatten out any high spots because don't want that where we're going. But then there's these like wear marks, and I don't know where those came from. Well, let's get it back together. Okay, so we got these on, and I believe I like how it's all sitting, and this whole assembly can kind of wobble around. I think it's because we really are just squishing the O-rings in there that you saw, the orange O-rings. So I'm going to go like this, tie it down a little bit. We just want to make sure we're doing even pressure as we get all of these in there. That way, it's not going to tweak those O-rings at all. So see, that one's kind of making some contact. So, well, the camera died right at the end there, but we do have the cylinder head all hooked back up. We do want to get the body on. If you guys didn't know, this is a fan. And so as it's pumping up, the protective body on this that I took off directs the air over the cylinder head, over the motor, and out the back to help cool everything. And so we do want to run it with the body on there. And that way we don't overheat anything. But hopefully this is a lot more efficient, and maybe we need to get a new air filter because, as you guys saw, there's a bunch of crap in there. So let's clean up the body. I want to clean up these gauges a little bit, and then we're on to testing. Let's go. Alright, we are back together, dry it up, everything should work again. I guess we'll see how good it does. So it's going to try to get up to 150, and if we can get up to 150 without this protection kicking off, then we're doing pretty good. So let's try it out. Alright, fire in the hole. Well, that gives us our answer. I screwed up. Yeah, that O-ring is chooched. My bad. Alright, well, I tried super gluing that. I thought I was recording, but apparently not. So we're going to let that super glue cure a little bit, put it back together, and just see, because I don't have any O-rings that fit that. So we're going to have to order something, but... Alright, let's put it back together and take two. So I think I found an easier way to actually test if this is working or not. If we take our other air compressor, and we take our rubber tip on there, then we should be able to put 80 psi in through this side, and look at that. So no. Well, maybe we just need to get a new valve completely. So I still think it's our valves. I think we fixed our O-ring, but I think our valves right there are not doing too hot. All right, well, I've got some 1200 grit sandpaper and a little bit of water. And we're just gonna try to lightly scuff these back to being smooth, and then we'll do the same on the other side. So I ran out of time filming the other day, but since then I've found, you know, little tidbits here and there, and I've played around with a bit. As you saw, it still did not work, but I don't think, there's still a couple things before I just order a whole new valve plate. So I'm playing around with this. There is a check valve down here, so I think that's why once it gets up to pressure, it doesn't leak back through here anymore, is because this valve is stopping it. So I was wrong that it heated, like after it got hot, it would keep it from rolling back. No, it's this down here that's keeping that. Other things, what I did is I took apart this yet again, and I think I filmed polishing them up with 1500 grit sandpaper. I also bent the reeds a little bit. So the reeds were sitting like this, you know, just barely on it, and I bent them down, so now they're pushing down. And when I did that, I got a lot better performance, and they're actually sealing pretty well. I think this might work. The last thing here is when I was testing it, I think I feel a bunch of air coming out from this connector right here. So what we need to do realistically is get some Teflon tape on this guy. And I think between all of these, then we might have a pretty dang good shot. So, you guys hear that? That started happening once I actually started putting a bit of pressure on the reed valves. And it seals out a lot better when I do that. So, hopefully between those and this, it'll work. But let's put the cover back on, just so it doesn't overheat, and give this one last go before we just straight up order parts for it. All right, let's see if it works out. And also one last note, down here, this relief valve, this is the safety relief valve, which sets off above the regulated pressure. So I was wrong there. It's not just a release, but I should make sure that we are locked up on the bottom. All right, everything should be buttoned up. Let's give her a go. Well, that shut off pretty dang fast. I've made it worse. All right, well, let's find out if humility is the answer. I did order a new plate and a new air filter, so I can stop trying to, stop worrying if it's the air filter, and this should have the right pressures on there. I think what happened is I made it too tight. The pump was overworking, so then it wasn't pumping as much air as it could, and it overheated. So let's see, 0 PSI. Let's take this apart and see if new parts make things better, shall we? Okay, so this, that already sounds a lot healthier. I don't know much about air compressors. I don't have much experience is what I should say, but that sounds pretty healthy. All right, here's hopefully the last time. I guess we'll see. Cross your fingers. Let's try. That's frustrating. Okay, so maybe we've been looking in the wrong place, because here's my thought process. We got up to like 50 PSI almost, and it's supposed to be like 150. And we have all these placards on here to be like, hey, don't burn yourself, it gets really hot, you know, warning. And when we get to 50 and it kicks off, the circuit breaker kicks off, I mean, sure, it's warm, but I can still touch it. I'm not like immediately burning my hands when I touch it. So I almost wonder if maybe this whole system is actually supposed to run a lot hotter, but the circuit breaker is tripping before it should. I mean, that's just my thought process. So I think what we want to do is actually pull this apart and see if maybe, I don't know, maybe we can find something in there or clean it out. I want to see how the circuit breaker works, because it was pretty dusty in the motor when I was first messing with it. So maybe some dust is causing it to prematurely trip, and it is supposed to actually be able to go all the way up to 150 without tripping. And it's supposed to run hotter than it's letting it run right now. So let's try that and see how it goes. So on these, I was trying to pull it off, but there's actually a little itty bitty tab. There's like the hole in the blade, and then this terminal comes on top, and there's like a little pin holding that in. And as you can maybe see right here, there's a little tab, and so you've got to like push down on the tab, and then it'll come out. So these are locking. So let's look on this side. That seems like it's kind of burnt, honestly. Well, that might be the issue right there. I mean, that blade terminal was definitely a lot more crusty. I don't know, I'll look at it. Okay, so looking at these, yes, this one side definitely was getting pretty dang hot, or has gotten hot at some point. And I don't think this matters, but it does label this as the line and that as the load. And they had this swapped. So this is the line coming in, and then here's the load, and they had the line in on the load, and they had the load on the line in. What I'm gonna do, I've cleaned these off a little bit. I'm gonna crimp these down a bit more so that they like are really stiff going on there to hopefully make a better connection on here. And then I think I'm also going to pull apart this this centrifugal switch here. But I just want to clean off the contacts to get it hopefully to work as best as possible while we're already in here. So, and to crimp these, we're just going to literally go like this, but maybe not as aggressive as that. Just try to bend in these two tabs ever so slightly so that way they make harder contact. When I move the line in terminal, it moves the button on the top. I don't know what that means, but yeah. I'll clean up these and then we'll put it back together. Hopefully you guys can see this, but the way these things work is as it spins up, this will pop out like that. And the contact's right there. So I will put out a PSA, don't do this, because without the back on here, you can eat your fingers right up when that is spinning. And you have, you know, 120 volts right there. So you can pretty easily damage or kill yourself like this. But for YouTube, for the shot, and hopefully you guys can see the gauges a little bit over here, but we'll just see what happens on the motor side. All right, we're going live. No one touched the back of the motor. Circuit breaker is on. See if this works. 3, 2, 1. Guys. That works. Well, of sorts. So there we go, it fixed it. Well, okay, we still have a little bit more work, but hey, that was the issue. That was the main issue. It wasn't the valves. Yeah, we spent a bunch of time there. It was just a loose connection on this circuit breaker, which is a little warm, I will agree. Now we have something else to deal with. It overpressurized a little bit. It's at 155 right now, and you can hear the air coming out of there. That's this pressure switch that, I don't know. When I messed with the ball valve, or with the valve down there, that's when it kind of started doing that. So we have a little bit more to dig into, but that was the main issue. You know, it's this, and it can run for so much longer than it was, like holy crap. So when I thought I broke it worse, it really wasn't actually breaking it worse. We're gonna let the pressure out again. Oh, and the other thing too, what's happening right now is we are getting some air back through the pump, which means that when I took apart and messed with the one-way valve into the tank, because again, at a certain pressure, actually at most of the pressures, you should let pressure into the tank and not back out. So if we're leaking through the pump head, then it's probably because of that ball valve. And I did read online that not ball valve, but it's because of that valve. And I did read online, if that valve is not working correctly, then this might not work correctly either. So, but we fixed from air coming in and into the tank almost with that valve. It is working. So we need to get the shut off. Let me button this up so this is safe. We can start working on that. I'll let out the air too. So we just want to check this valve because the, what is it? Under pressure relief or whatever. Didn't start having issues until after I touched this, which I think was off camera. So, my bad. Yeah, it's just a little spring and a little seal that I thought I put the right way around, but maybe I did not. So this actually is different than what I was thinking. I don't know why I get so confused all the time. Both of these are before the valve, and then the valve dumps into the tank. So we pressurize the tank here, and then this valve should close the tank off, both to the pressure regulator and from the pump. And then the pressure regulator also has right here, I just kind of forgot it was connected to the tank. Right here is where all the air that we use on the out coming out. So this right here is part of the under pressure stuff. Anyway, so here's the little valve in there. And I'm like pretty dang sure I put it in right. There's big part of the spring, smaller part of the spring, and the smaller part fits in that groove perfectly. And then this inside groove right there fits perfectly to down inside there on the seat. So I think this is the seal, but part of me wonders if I had it backwards and when I pulled it out, but see, that doesn't make sense. That like, it's too big. That doesn't make sense. That doesn't make sense. That does make sense, and that doesn't make sense. So like this is the only way that makes sense, is like that. So still think I put it in right, but I'm gonna try to take my valve lashing tool that I have and just setting this in here and then try rotating it a bunch to get it to seal correctly. Maybe I need to sand this down a tiny bit so that way it actually sits on the seat a little bit. But I don't want to be too aggressive with this because I feel like I'm going to damage it. Okay, so here's what I've come up with. I have the foot from the scroll saw, which if you haven't seen that video, go check it out, with the bolt in it, and then into my drill, so that way I can do that. And this is pretty soft, so it should grab onto this piece, and then I can just rotate it a bunch and kind of lap it all together. So So as you guys can see in there, there's a little ring coming from this tube, and that's what we seal on. And then just past that is where the other tube sticks off, and then down from this, I can like stick my finger down into there, is where we go. Hopefully you guys can see this, but right here there's a nice little nick. And I feel like that's causing us, or that could cause us some issues. So let's try just taking this and getting that to go back out. Oh, that works too. I will say that little spot corresponds to that spot on this. So something smacked it pretty dang hard at some point to dent that in. But I just want to make sure this, yeah. Okay, that should fit in nice and tight still. And see, this little piece goes in right there. And that's what we're trying to spin. So as you can see, it didn't stop at 150, and as you can hear, it's leaking from down below, and there's like a little something down there. So it looks like I thought we were done, but no, we've got to start tearing into this now. I'm gonna let it kind of drain down a little bit. I want to see if when it's under 150, if it stops leaking down there, which it sounds like it does. So why is it not kicking off? All right, well, one of the last pieces we haven't touched looks like we're gonna need to touch. So, yeah, unplugged from the wall. Don't worry, we're being safe. Figure out how it works and fix it. Hey, at least there's a wiring on the backside, so that might help us. This thing, wherever it was before me, filthy, absolutely filthy, holy smokes. Inside and out, through and through. Okay, so taking a quick gander at this bar like moves a spring, and you can see the switch there. Yeah, that's what that does. And then looking at the back side of this, it tells us that these two screws are to adjust the different things. So this screw right here will adjust both when it stops pressurizing and when it will repressurize, and then this one adjusts just the stop pressure. So it sounds like we need to adjust this. Right now we're sitting at like what, 145 psi or so. So we should be able to adjust these a little bit and turn clockwise to increase cutout pressure without affecting cut in. So what we want to do here is go like this. Okay, so I think I figured out how this works. This plate right here is pushed by two springs. This spring and this other spring. And when the plate is up, like that, it shuts it off. So there's two ways you can push the plate up. Like this, or the pressure from the tank goes up. So you can adjust this big spring and the pressure on that, and that's this metal screw right here. See, look, I'm adjusting the pressure on it. And then I can also adjust the little, there's like this black one has like a little tiny bit of pressure in there as well. And so between the two, you should be able to adjust this to work like it needs. So then the question becomes, we have like 140 psi on our gauge, so why is it not adjusting out here? So let's see, clockwise to increase the pressure. So let's just decrease these all. So that's off. Then we go on. So on is when it's down. So if we tighten this up, then we could get it to kick on. Right? Oh, it's because it's off. So that's on, and then we adjust this out so it's off. Like that. Probably also want to adjust this guy out too, at least. See, I guess really what we should do is go to the bottom side. So go to 120. That's what everything's telling me to do. Turn on at 120 and turn off at 150. Let me air down to 120 and then we'll adjust it. Okay, so now I have it at 120 PSI, which means that's for sure off and that's on. So we'll go like this and then do this in until it kicks on like that. So again, we can bring out pressure on it. So now when we go to auto, see it's off, and then we'll just go in until it turns on. There. See, it's just barely will kick on once it hits 120. So I believe that should be correct. So now we need to get back up to 150 and adjust the high side. So, and again, this is open, so once we plug this in, no touchy. You do not want to touch there or else you'll get shocked. We'll plug it in, turn it into auto. See, it doesn't start, so we might have to let a little bit more air out of it. So let's unplug it. So that's like over pressure. So we'll let that come down a bit. This is what happened. This started leaking again. My one-way valve into the tank started leaking. And so I brought it down to 120. I wanted to get this set up to starting again. And I guess the pressure at 120 was enough to get it to starting again. If that makes any sense. This valve is really important for mainly one reason. It's so that way we don't have pressure up in our cylinder, so that way when we want to start again, we can start, because you know there's not the pressure pushing back. If not, then this motor can't start spinning because there's too much pressure against it. So if this is leaking, we probably can't start the motor when we are under pressure, and that's exactly what happened. I went to 120, I adjusted it back to 120, I went up to 150, and the smart side of me was like, oh, maybe if I keep trying to like reseal it and unseal it, I can just keep starting it until finally I get it to seal one time, end the video, maybe order a new one, I don't know. But I got up to pressure, I kicked it off, I tried kicking it on again, and it didn't start, and it like almost like tripped the breaker in here. It tripped the breaker in the motor itself. Maybe that's what happened. Maybe this is ultimately what failed. And then it kept tripping the breaker, and so eventually the spay terminals in here got dirty, and then it just, you know, it's where it's at. So, last ditch effort. If this doesn't work, then fine. I will order a new part. This is what I finally figured out for trying to spin it. It's just like a little piece of fuel tubing that I had. So then I can come in here, put this valve that is giving me grief in here, and then put the fuel tubing on it, get it to seat. And basically try to create enough friction to melt and make a new seal. At least that's the hope, anyways. I think there's some junk, and I think junk keeps getting caught in here. So again, don't run your air compressor in that dirty of an environment, because if it sucks in debris and it plugs this valve, then you could flip the circuit breaker, you could damage your motor. Yeah, I'm done with this. If you can't tell, I kind of just wish this would just work, but that's okay. The rubber on the back of this is getting mighty warm from that. Promise, if this doesn't work, I will order a new one. Whoops. Well, it is now a few weeks later, and I finally have a replacement ball valve, or like check valve here. So now we just need to replace that, and this should be ready to go. That should be it. So let's start replacing it. Well, that's not good. This has just got a whole lot more fun to try to do, so. If you didn't see what I did there, I cut 2 slots in it and then pushed in the one side so we could get it out easier. The valve is in. I'm pretty sure I've done it correctly, so we might as well go for it. I really, really hope this works. I'm a little done with this project, I won't lie. So, close the valve at the bottom and turn that to off. Fire in the hole. Okay, so it was pressurized and then so now the whole pump system is depressurized, but then we still got air in the tank. So other than making sure we have our on and off correct, this should be working. So let's let it get up and kick off at 150. Go from there. Hey, 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 hey. There we go. And maybe you can hear it. So our new valve works. Oh man, and it kicks off correctly. So I guess the only thing to do now is take out some air and see if it still works correctly. Let's see what pressure it kicks on at. I guess this is the one we're watching. It needs to kick on at 120, right? Or like right at 120, or even a little bit under. All right, let's adjust it. There we go, we set our low point. All right, unplugged it. So now we can work on right here. So all right, well, it looks like we can't adjust this upper one low enough to get it to kick off at 150. So let's see, we need to counterclockwise this until it kicks. All right, let's kick it up to 150 and then shut it off again. All right, well, our low point is going to be lower than 120, but that's okay. So we're just going to turn this until it kicks off at 150 because that is arguably more important than kicking on at 120. There we go. We should be good to go. It'll kick on, I don't know, probably 110 or so, and then kick off at 150. Well, what a project, guys. This one took a bit longer than I thought. Granted, it's probably pretty short for you guys, but we finally got it running. We took the long route, but we got it done. So, really excited to have a lot more air because my other one is just, it's not holding up right now. And having air is actually really useful. So, really glad that I got this running and really glad that you guys come along on this project with us. I hope you guys come on the next one, but until then, have a great day, and we'll see you later. Bye!